Okay, this is chapter 6 for chemistry, chemical composition. Alright, this chapter is going to be dealing with atoms and moles. We've already determined chemical formulas, and we will be determining the number and type of atoms in substances. So you've put together formulas, now we'll understand what the formula actually means. And then we'll also look at atoms, which are too small to count individually, so we'll look at ways of dealing with that issue. Alright, the first thing I want to go over are averages, which we've already covered, but I'd like to do it one more time, and in particular what's known as the weighted average. So an average means you add the individual measurements and divide by the total number of measurements. So for example, if you have the numbers 1, 7, and 9, and I asked you to take an average, the first thing you would do is add them. 1 plus 7 plus 9 equals 17. And then why did I take 17 and divide it by 3? That's because there are 3 numbers, the 1, the 7, and the 9. So the average would be 5.6. Or you could have rounded up to 5.7. Okay, now how about these numbers? Okay, when you have a list of numbers, the first thing, add them up. So 32 plus 36 plus 38 plus 45 plus 2 plus 18 equals 171. And then why did I take 171 and divide it by 6? Because there are 6 numbers that I added together. And that average is 28.5. Okay, now we can relate this to your grades. Okay, so let's say that I as a teacher have these 7 scores as test grades. So I take the 100 plus 86 plus 95 plus 82 plus 97 plus 53 plus 72, and that gets me a total of 585. And why do I take 585 and divide it by 7? Because I had 7 test grades. So this average would be 83.6. Okay, now what if I had these 4 scores, like your first 4 chapters in this class? Let's say you had a 76 on a test, and then a 78, a 93, and then a 64. Add them up to get 311, and then divide by 4 because you had 4 tests. So your average is a 78. Okay, so we have what's called a weighted average, okay, and weighted averages will actually take into account more than just like the number of scores, okay. So what could happen is I have 4 classes a day, so I could look at how many of my students got 100, how many got an 80, or how many got a 10% on the test. So I'm taking the number of students by that test score. So right here you've got 23 times 100. I have 23 students get 100 on a test. Multiply that, you get 2,300. 15 of my students got an 80. Multiply those two to get 1,200. 5 of my students got a 10. So times those and you get 50. The next thing I do is add those values, 2,300 plus 1,200 plus 50, and I get 3,550. Okay, now how many students is this? It's the 23 that got 100, the 15 that got an 80, and the 5 that got a 10. So 23 plus 15 plus 5 is 43. And then I take those 2 values and I divide them. So now I'm counting for what the test score was and how many students got that score. Okay, so the average was 82.6. That's called the weighted average because I accounted for the score and the number of students. Okay, now why couldn't I just add the 100, the 80, and the 10 and divide by 3? Because each score is represented by a different number of students. And this is like your GPA. You have something called a weighted GPA because it takes into account the type of class that you had. I believe an honors course, an A would be worth like 4.5, not just 4.0. And in an AP class, an A is worth 5.0, and you'd also get college credit. So when colleges see your transcript and they see that you've taken different levels of classes, they will look at your weighted GPA to see how much you pushed yourself. Okay, so weighted averages take into account the value of the data. Alright, now what does this have to do with chemistry? Well, we have something in chemistry called an isotope, which you've already learned this. It's different forms of the same element with different numbers of neutrons. So if you look at this picture, If you take a look at hydrogen, it says hydrogen 1, we see 1 proton. Okay, hydrogen 2, you see the proton and the neutron. And then hydrogen 3, you see the proton with 2 neutrons. So in each picture, you're getting a different number of neutrons. Hydrogen 1 has none, hydrogen 2 has 1, and hydrogen 3 has 2 of them. So these are isotopes of hydrogen. Okay, when you look on the periodic table, what we looked at as the mass number is actually known as a weighted average or relative abundance of those isotopes. So in this example, most hydrogen atoms have a mass of 1. Okay, and that is the number you see either above or below the symbol for hydrogen on the periodic table. Mass number will never be a whole number because it's a weighted average and appears as a decimal. Okay, so now this is what your work will look like today. I will give you isotopes of, say, something like carbon. So you see the C12 at 98.89% and C13 at 1.1%. That means there's 98% of carbon-12 and 1% of carbon-13. Carbon-12 and carbon-13 are 2 isotopes of carbon, and you have to deal with this in order to come up with the mass number for carbon on the periodic table. So if you look at step 1, you will take 12 times 98.89. Then you will take the 13 and times it by the 1.11. So you're taking the different mass numbers and multiplying them by the percents. Step 2, you will add those two values to come up with 1201.11. And then since this is a percent, you're going to divide it by 100. And you can check your answer on the periodic table. If you look up carbon, its mass number is 12.01. And just so you know, we will use the term mass number, which does refer to grams, but it really is supposed to be AMU, or an atomic mass unit, because atoms are really, really tiny, and it's hard to say that those are weighted in grams. So it's technically an atomic mass unit, but we will interchange that with grams just for ease of working with the data.